In this video, I will explain how to solve productivity-related problems using Microsoft Excel. So here are some problems, and the first problem is that a catering company prepared and served 300 meals at an anniversary celebration last week using 8 workers. Okay, so let's look at this sentence and try to identify outputs and inputs in this problem because it's about productivity and one of the formula for productivity is it's a ratio of output and input. So what are the outputs and inputs in this case? So of course they are serving 300 meals, so that's an output, and they are using this number of employee, that's 8 workers or 8 laborers. So 8 workers becomes an input and 300 meals is an output. Okay, so I will write it here in Excel that output is 300 and labor input is 8 people. And then there is another a piece of information. The week before, 6 workers prepared and served 240 meals at a wedding reception. So a week before, they were producing 240 meals, which means that's a productivity. And at that time, they were using 6 workers. So I will separate them by this, which means I will be making two, I'll be making 4 columns. These 2 columns, they represent uh, 1 week, and this represents another week. And the formula for productivity is it's a ratio of output and input. So I will press here is equal to sign and 300 divided by 8. Click 8, and that gives productivity of 37.5, which means when 300 is divided by 8, that's 37.5, which means they are producing 37.5 meals per unit worker or per unit labor. So that is their labor productivity. Similarly, we can also do the same thing here is equal to and then 240 divided by click the sixth and that's 40. So which means in this case, their productivity is 40 meals per worker. So that's all about labor productivity. And if we look at the question, and the question says, for which event was the labor productivity higher? So we can see that in this case, when 40, their productivity was higher, which means the week before, this is current week and this is the week before, their productivity was higher because 40 is greater than 37.5. So these are two productivity values, 37.5 and 40. And since 40 is greater, so that productivity is higher. Then next part is what are some possible reasons for the productivity differences? Some possible reasons could be, there could be many reasons. For instance, you can say that menu was different. On this event, there were different type of food served, and on this event, a different type of foods were served, and preparing these type of foods, it takes different time. That could be one reason. Another thing could be that maybe we don't know what time and day these events work. So for instance, let's say if one of these events was on Monday, so you can imagine that someone might be a little bit tired on Monday. That's after Sunday, and maybe their productivity was not as much high. So there can be many other reasons. But the thing is that the answer to this question is qualitative, which means you write it in the form of a sentence. There is no numerical answer. For the first part, there's an answer that starts 7.5 and 40, but for this one, it's just a statement, qualitative answer. Then the next question is that the manager of a crew that installs carpeting has tracked the crew's output over the past several weeks, obtaining these figures. Now, again, identify what's output here and what are inputs. So in week one, for instance, crew size was 4 and they installed 96 yards carpet. So of course it means this is output and crew size is input. So I will enter this data here. Now here, for instance, I have already entered this data, and here we have week and then crew size and yards installed. And because we are supposed to calculate labor productivity is the ratio of output and divided by the screw size. So that's a formula I'll be using. So labor productivity is equal to 96 divided by select this cell, and that gives you labor productivity, that's 24. And then you can drag it down and that will give you productivity for the whole week. Okay, now let's move to the next question. The next question says, compute the multi-factor productivity measure for each of the weeks shown for production of chocolate bars. What do the productivity figures suggest? Assume 40-hour weeks and an hourly wage of $12. Overhead is 1.5 times weekly labor cost and material cost is $6 per pound. Okay, let's um, look at this problem in depth. So first of all, it's about multi-factor productivity. The questions that we're doing earlier, they were about labor productivity, but this one is about multi-factor productivity. And multi-factor productivity is that it's the one in which we take the ratio of output and all inputs combined. So this is the formula, as you can see here, that this is output. In numerator, we have output, and in denominator, all type of inputs, they are combined. So that's called multi-factor productivity. For more details, please see PowerPoint slides. Okay, now here we have, this is our output, and actually it's very specifically mentioned here that this is output, which in the week one was 30,000 units of chocolate bar. And then another, um, one input is worker, which means they were using 6 workers, and material used in making these chocolates was 450 pounds. So okay, so here I write that output is 30,000 units of chocolate, and there are 6 workers and 450 pounds of material, such as sugar and chocolate, ingredient, raw material, all these things. 450 pounds were used. Okay. And then there is another piece of information that these people, they are working 80 hours a week, which means these labor people, there are 6 workers. These 6 workers, they are working 40 hours a week. Let me draw it here. So as you can see here, that they have these 6 workers, and these workers, they are working 40 hours a week, and then they are paid at the rate of $12 per hour. So that's the complete information that's required for calculating labor cost. So that will be one thing. Again, so as you can see here, in this we have labor cost, and labor cost will be the product of 6 multiplied by 40 multiplied by 12. That will be labor cost. That's one input in the denominator. And then the next thing is material cost. So material cost, we know it's here. It's $6 per pound multiplied by 450. So that will be material cost. That's a product of 6 and 450. And the last type of input is overhead cost, which is 1.5 times weekly labor cost. So the labor cost that we calculated earlier, we will multiply that by 1.5. Okay, let's do it. So I will say here multi-factor productivity is equal to, first of all, output, and output uh, that makes up numerator, that's 30,000, and then divided by, so in divided by, let's say first labor cost, and labor cost, we know there are six people, six workers. So six workers multiplied by, they work 40 hours and they are paid at the rate of $12. So that becomes our labor cost. C2 represents workers, number of workers, six worker, and then 40, that's number of hours they work a week, multiplied by 12, that's dollar. And this whole chunk, it represents the labor cost. Okay. And the next thing is, let's add here overhead cost. So as you can see here, overhead cost is 1.5 times weekly labor cost. So which means this labor cost, if we multiply it by 1.5, that will give us overhead cost. Okay, so I will write here 1.5 times multiplied by, I will copy this one and paste it there. So that becomes overhead cost because overhead is 1.5 times weekly labor cost. So this was our labor cost. And to calculate overhead cost, I multiplied this one by 1.5. So you can see here 1.5 multiplied by C2, which means number of workers multiplied by 40 hours per week and multiplied by $12. And the last input here is material. How much material is being used? And for that, we know they are using they are using 450 pounds. So this 450 pounds multiplied by the cost per pound is 6. So I will manually enter here 6, and that's it. So we are done with this whole calculation. Now, before I hit enter, let me explain it one more time. So in this formula, what we have done is that B2, that's numerator, which means our output, that's 30,000. And this chunk, this piece, it represents labor cost. And this piece in parentheses, that represents overhead cost. And this piece, it represents material cost. And if I hit enter, it gives us a multi-factor productivity that is 3.03. All right. And then using the same approach, you will be calculating multi-factor productivity for week 2, week 3, and week 4. Okay, now let's move to this last question. That's a company that makes shopping carts for supermarket and other stores recently purchased some new equipment that reduces labor content of the job needed to produce the shopping carts. Prior to buying the new equipment, the company used 5 workers, or that's one piece of information. So I will highlight it that they are using 5 workers, which means that's input that will be used in this question, who produce an average of 80 cards. That's another data point, 80 cards, and that's output. 80 cards, what they are producing is output. This 5 workers is input. Workers received $10 per hour. Now that's another piece of information that's related to input, because this is about worker compensation, which means the company is paying all these things. They are paying 5 workers $10 per hour. And then there is another input that's $40. Machine cost is $40. Okay, so we have all the inputs and output again. Output here is 80 cards, and one input is 5 workers, and they work 40 hours. No, sorry, that's machine cost. So 5 workers will be multiplied by 10, and then to this will be adding $40 per hour. That's machine cost. Okay, so if I enter this data here, here we have. So they have 5 labor and output is $80, and labor cost is $10 and machine cost is $40. Now they have two system. So in the next sentence, they say with the new system, it was possible to transfer one of the workers to another department. So initially they had five workers, and when they transferred one worker to another department, now in the new system, they are left with four. So which means here we have four workers, and then it says equipment cost increased by $10 per hour. So initially machine cost was 40, now it becomes 50. And then it says output increased by 4 cards per hour. Initially, their output was $80, cards, and now it becomes 84. And labor cost remains the same. And they haven't mentioned anything, so which means labor cost remains the same. Now, we are required to make a comparison. The first thing is we will be calculating labor productivity. Labor productivity is rather straightforward, which means we will be dividing output by labor or number of workers. That's it. So the number of labor, not the cost, because it's labor productivity. So for labor productivity, I'll be using this formula output, that's 80 divided by number of workers. That's it. So, and that gives 16. So, which means their labor productivity in the old system was 16. In other words, it means they were making 16 cards per worker or per unit employee. And again, you can just drag this one to the next column and it will give you productivity for this one. So here I will do click on this one and then drag it. As you can see this cross at the bottom right end, then drag it, and that gives 21, which mean in this system their productivity is 21, which means 84 divided by 4. Okay, and the next thing is multi-factor productivity. And again, in multi-factor productivity, it is the ratio of output and all inputs combined. So let's say, what's the output here in multi-factor productivity? That's output 80 divided by, and what are inputs? So the first input we know is labor, which means 5 multiplied by their cost, that's $10. And then there is another input, and that is machine cost, and that's it. So that's our multi-factor productivity. And as again, you can see here that in multi-factor productivity, this is this B3, that's our output, which means in this case, it's 80. And then here we have labor cost, and then this is machine cost. And as you can see here, I'm using multiple parentheses. And the reason is that because I want to consider this whole as a denominator. So please make sure that it's appropriate to use the right number of parentheses. So if, you can see here, if I hit it, it gives us something 0.888, or if I round it off, it will be something 0.89. And if you don't use here a right number of parentheses, so for instance, let's say if you just use one parenthesis here, I mean, that would be wrong. And let's see then what happens. Then it gives 41.6, which is wrong. So therefore, it's important to use the right number of parentheses. No, so first of all, this piece, which is in parentheses, that represents labor cost, and this is a machine cost. And because I want to consider this whole as a denominator, so therefore, I will put this whole in parentheses. Now, it means by adding these extra pair of parentheses, which this numerator, it will be divided by this whole, not just by one of them, and that answer would be added to this B5 or machine cost, but rather it means that this B3 is being divided by this whole um, sum. Okay. And then, so when I put these parentheses and I hit enter, that would give me 0.89. And then if I drag it on this side, it will give me multi-factor productivity for this system, and that's 0.93. So that's our multi-factor productivity. We got labor productivity, we got multi-factor productivity, and the last part is that comment on the changes in productivity, which means how much percentage change is happening, which means when you're moving from 16 to 21, what is the percentage increase? We know there's an increase of 5 units, but we are not talking about absolute number. We want to figure out percentage increase in productivity, not only for labor, but also for multi-factor productivity. And the formula has been given in slides. It's also given here. As you can see that this change in productivity is this thing, that's current productivity minus previous productivity, and that is divided by previous productivity. So let's go with this one. Let's say, for instance, if I go with this one, that's multi-factor productivity. So that would be current productivity. So that's current productivity. And let me put it in parentheses. So that's current productivity minus old productivity, and that's previous productivity. And then I'm going to divide it by previous productivity. And that would give me um, change or delta in productivity. So if I hit enter, it gives me 5% or something close to 5. And there is a possibility you can increase the number of decimal places and you can decrease them. Um, so that's 5. And as you can see here that this answer is slightly different from the answer that you have here is 4.49, and the reason is this rounding error. So here we are using 0.8888 and it keeps going, but over here we are using 0.89. Here we are using 0.9333, but over here we are only using 0.93. And the same thing goes here. We are dividing this whole by 0.89, and over here we are dividing by 0.88. So because of this rounding error, the answer might be slightly different. If you do it manually, you will get 4.49. If you do it on Microsoft Excel, you might get this answer that's a little bit different. And the next step, you will calculate changes in labor productivity, which means delta, how much change has happened when you make this transition from old to new, which means a change from 16 to 21 is what percentage. And one last thing, there's a possibility that you may not get this thing, or you may get something different, uh, a different type of number. In that case, you need to click here on percentage. So for instance, if you get something, um, let's say zero point 0.05 or something, just click on this percentage and that would give you the answer. That's all about how to calculate productivity and multi-factor productivity using Microsoft Excel.